port. Now let's try to understand what is a one port network. What is an one port network? We have two port network and n port. Let's try to understand what is meant by one port network. So any network can be diagrammatically represented. So we are saying a network that can be represented via an rectangular box. This is an rectangular box which consists of two terminals. This is terminal 1, this is terminal 2. So port means we can call it as an two terminals. We have two terminals or a pair of terminals. So how many you have? A pair, or you have two terminals, then it is called as an port or one port network. This is how to draw a one port network. So next one you have two port network. Two port network. So what is an two port network means? Here you have two ports. One is an incoming port, one is an outgoing port. So I'm going to draw the port like a rectangular box. So first port is input port, or where it is called as a driving source port. Okay, this is an input port, this is an output port. So this port you are going to call input port, this is called output port, and this is called, two ports are there, therefore this is called a two port network. So this is also called driving source. This input port is also called drives to get the output, therefore this is called a driving source or driving port. Driving source or driving port. So here how many terminals are there? Already I told, a port means you have how many terminals? Two terminals. This is called input port. Output port also has two terminals. Those are labeled as 3 and 4. This is called output port. So therefore in an two port network, we have four terminals. We have four terminals. So this is how to draw an diagrammatical representation of an, this is called diagrammatical representation of an a two port network. So now similarly let's try to understand an n port network. What is an n port network? So here we understood only we have two ports. So now we may have more than two. That's what it's called n port network. So I'm going to draw an n port network. Already I told in the previous class, you can see network means some group, more than one electrical circuit, or group of electrical circuits is called network. Network means a single closed path is called network. This is an n port network. So here you are going to have port 1. So this is called as a port 1. So I am labeling it as 1 and 2. I have one more input. This is called as port 2. I am labeling it as 3 and 4. I am going to have one more input. This is called as port 3. So 1, 2, 3, 4, 5, 6. And here I am going to take the output. I am going to call it as an output port. So this will act as an 7 and 8. So this is I can call technically now a 4 port network consisting of 4 twos are 8 terminals. 8 terminals. So I can take here port 1 as an, to this port 1 I will connect an diesel generator. To this port 2 I will connect one more generator, and here I will connect a solar system. So like this, these are also DC supply. So you can connect electricity, or you can connect a generator, or you can connect a generator to, or you can connect a solar system. Ultimately they give the output. Therefore here you may have more than one, therefore it is called as n port network. This is all about the representation of an port. Port means we have incoming and outgoing. Okay, so we have incoming as well as the outgoing. Okay, so you have the open, you have incoming as well as the outgoing, where we have loading of ships or unloading of ships. So you have two terminals. For why two terminals? To connect the voltage. You may have why you require two terminals to connect the voltage. Definitely you require two terminals. One is of higher potential and one is of lower potential. That's why you require two terminals. This is called a port. Let us try to see here network configurations. So what are different electrical network configurations one by one? This is network configuration is very important. So first network configuration what we are going to discuss now is a T section. Okay, T section. So configurations, there are multiple configurations. So this is like how you arrange those RLC components is called configuration. So I'm going to arrange them like an T. Let's try to see here how I'm going to arrange now. Okay, so I'm going to draw a T-type network. So here I'm directly drawing the impedance. I'm labeling this impedance as some Z1, and I have one more impedance. This is the second impedance, and at the center I have one more branch. This is called as an impedance. So this is called input. So this is called input port, and this is called output port. I'm labeling this as some Z1, and this also as Z2, and this as Z2. So here Z1 and Z2 are called as a series, they are connected in series arms. This Z2, sorry, this Z2 is called as shunt arm. Why? Because it's connected in parallel. Shunt arm. For example, if you take Z1 is equal to some 3 plus J4 ohms, and Z1 is also 3 plus J4. So now we want to identify whether it is a symmetrical T network or an unsymmetrical. So now we need to understand what is meant by an symmetrical. Symmetrical T network. So this resembles like a T letter. That's why this is called T session. Sir, what is symmetrical? Symmetrical means you can understand having exactly matching parts. If you have exactly matching parts each other, if you have exactly matching parts facing each other. So what are these exactly matching part? For example, you take a white paper. It's like a square white paper, and you fold this white paper into half. Then you are going to get a white paper like an rectangle. So when you fold it, it resembles like, so the area occupied by this half is also equal to the area occupied by this half when you fold at the center. So therefore the length, the area in this rectangle get mapped with the area of this automatically. When you fold at this point, when you fold this S point, this seems to be like an rectangle. Therefore exactly it has the matching parts facing each other. So this is called symmetrical. So what are the examples of symmetrical? Means your eyes are symmetrical placed, your legs, your hands, notebook, you fold your notebook, it is also symmetrical. Okay, so all these are the examples of symmetrical. So now when you see here, so I'm going to fold it at exactly at half. So I'm going to fold it at the dotted line. If I fold, this value and this value is same, therefore I can say fold it, Z1 is equal to Z1. when you fold it. So both are same, automatically they can match each other. Therefore I can say this network is a symmetrical T network. So then what is unsymmetrical? So Z1 value should not be equal to Z2. Now I'm going to redraw it. So this is some Z1, and I have one more element. This is Z1, this is Z2. I'm having an shunt branch. Let's try to take already Z2 is there. No, let's try to take this is some Z3. I'm going to have this is Z2. So this I'm going to apply voltage of V1 input port. It draws a current of I1. So here I'm going to apply a voltage of V2. It once again takes a current of I2. So this is Z1, Z2 and Z3. So how to say this is symmetrical or not, I already told. So if you fold the book, your notes is there, you fold this book, automatically only the notes will seems to be like an rectangle. That's called symmetrical. So similarly, when you see here, so Z1 value I'm taking it as some 3 plus J4. Automatically I'm taking this Z3 value as 4 plus J5. All these are the impedance I'm representing in ohms. This is the form of R plus J, R plus J XL. R plus JXL. This is a R plus JXL form. So here I can say that Z1 and Z3 are not equal. If they are not equal, I can call this network as a unsymmetrical. I can call this as unsymmetrical. This resembles like a T. It's called unsymmetrical T network. So this is called symmetrical T network. This is called unsymmetrical T network. Here Z1 and Z2 both are mapping. So the value of Z1 and Z2 both are same. That's why it is called symmetrical. So when you match, both are matching. Here Z1 value is not equal to Z3. Therefore it is called unsymmetrical T network. So this is all about symmetrical and unsymmetrical T type of session. So hope you understood what is meant by symmetrical and unsymmetrical network. So coming to the next one, balanced and unbalanced configuration. Okay, balanced and unbalanced configuration. Configuration means the way of arranging the resistance is called configuration. Balanced and unbalanced configuration in an two-port network. Let us try to consider here. So balanced means it's very simple to understand. So I'm taking a network consisting of some Z1 and one more impedance Z1, and I'm having a shunt branch like this, and I'm going to call it as some Z1. This also Z1. This is some Z2. This is input port. I'm labeling as V1. Current drawn is I1, and this is an output port. I'm applying a voltage of V2, and the current drawn by the network is I2. So I can call this as a symmetrical T network. But what happens here is, this is balanced or unbalanced, we have an doubt. So how to make it balanced is the weight at this point and this should be same. So now I'm going to take half portion of this, and this is like an closed path. This Z1 I can write down it as a Z1 by 2 plus Z1 by 2. So take the LCM is 2. This is Z1 plus Z1. This is nothing but 2Z1 by 2. Therefore the total impedance in the input is Z1. So this I am going to redraw it. and I'm going to get as this is Z1, leave it here, and at input side you draw one more impedance. This is at input V1, drawing a current of I1. This is Z1 by 2. This is Z1 by 2. Z1 by 2 plus Z1 by 2 is resultantly Z1. And the shunt branch you are going to have where this is nothing but Z2. And you are going to have the series branch, this next one, which is nothing but Z1. So here you are having Z1. Similarly, you do the same. You are going to have Z1 by 2. So at the half session, you divide, and what is the resultant impedance we have in this half session? The dotted line is only Z1. So this Z1 I am writing it as Z1 by 2 plus Z1 by 2. So I am going to write down this as Z1 by 2, and this is an output port. I am applying a voltage of V2 and the current drawn is I2. So this is actually what's happening here. So now when you see in this half, you can see the weight at the upper side is there and the weight is there at the bottom, and therefore this is like a balanced. And you can see here the weight is there at the this series arm and weight is also there at the bottom arm. I can say that this network is called as an balanced one. So this is basically now after writing Z1 as Z1 by 2 plus Z1 by 2. This branch Z1 as Z1 by 2 and Z1 by 2. So you can see if you draw a line, a vertical line like this, and if you see that the weights are balanced, this Z1 by 2 and Z1 by 2, Z1 by 2 and Z1 by 2, I can say the network is balanced now. Therefore, I can call this network as an balanced network, but basically before balance is like what? Symmetrical. So why? Because Z1 and Z1, this is a balanced symmetrical T section. This is a balanced symmetrical T section. These type of balanced symmetrical T sections are called as H sessions. You can see this network. So this is like a letter H. Therefore, balanced. So a balanced symmetrical T sessions are called as H sessions. It's very important. So how to understand balanced? It means the area at this point and this point at the bottom and top should be same. Therefore, then only I can call this as a bottom. So the amount of impedance at the upper and the bottom should be same, and only I can call this as a balanced symmetrical. Why it's symmetrical? This is Z1. This is also Z1. That's why it is called symmetrical. This is basically derived from T network. That's why it is called balanced symmetrical T network or T session. Now we need to understand, sir, what is the meaning of balance? The meaning of balance is nothing but the even distribution of weight. This is nothing but even distribution of weights, or situation in which elements are in correct position. So let's try to understand what is this even distribution. So the weight at the top is Z1 by 2, the weight at the bottom is Z1 by 2. The weight is distributed, therefore this is called even distribution of weights. Therefore this network is called a balanced symmetrical T network, and balanced symmetrical T network is called H network. That is all about T network symmetrical. So that is what we discussed now. It's very simple. So this is called one port with two terminals, two port with four terminals, and an N port like this, and an N port network with four terminal I'm taking, therefore I'm having 8 terminals. So T session, this is like an T, and if the impedances are same, then it is called symmetrical. If the impedances are different, then it is called Unsymmetrical. Symmetrical means folding at one axis is called symmetrical if both folding is same. So balanced means the weights are evenly distributed. The weights are evenly distributed, then it is called, these weights are evenly distributed, then it is called balance. So here you can see here the weights are uniformly distributed, therefore this is called as an balanced symmetrical T network, which is called H network. Hope you are able to understand. We'll continue with the pi session, balanced pi symmetrical in the upcoming session and L session. So if you are find the content is useful, please like the channel and please share with your friends, and if you have any doubts, let me know in the comment section. And if you are watching the channel for the first time, please subscribe the channel. Viewers obediently Ram. Okay, so this is a free channel for the benefits of students as well as faculty to upskill their knowledge. Thank you for watching. We'll meet in the next video.